All right, friends. So we'll start with Apache Hive. We discussed about Apache Pig in the last class, and Apache Pig is used for ETL, right? And here schema is optional, right? That's your Apache Pig. And in Apache Pig, the language basically that we are writing is called as Pig Latin. And it's also known as procedural language. It's called as procedural language. And it has Pig engine, basically contains parser, then it contains compiler, right? Parser, then it contains compiler, then it contains, sorry, optimizer, my bad. Optimizer, after that we'll have compiler. Compiler, and we have executor. Right, these are the four things that your Pig engine consists of. And the high level code that we are writing is getting converted into map and reduce jobs, and those map and reduce jobs get executed on HDFS. Whereas Pig can work on local as well as on map reduce. And to start here, we say pig-x local. Here we can either say pig or we can say pig-x map reduce. These are the ways to start the Pig execution. The most important thing is schema is optional, guys. Remember that, okay? Schema is optional. That means we can work with structured data, semi-structured data, and unstructured data. Right? No problem. It started with Yahoo. Okay, they wanted this ETL task to be done. That's the history of Apache Pig, and we have seen how to load the file, how to join the data, right? Then we have also seen how to filter, flatten, a few of the commands that are popularly used in Apache Pig. We have basically walked through. Now, we'll also see another tool which is called as Apache Hive. Okay, let me load Firefox. Please do this along with me, everyone. We will be downloading the software now. So launch Apache Hive, right? We will say hive.apache.org. Hive.apache.org, or you can also say Apache Hive download in Google, and it will redirect you to this open source website. Right, on the left side here, you see downloads. Apache Hive is a data warehousing solution. Right? Pig is ETL, it is used for ETL. Hive is used for data warehousing. Right? And organizations use both or maybe one, right, for basically getting their transactions done. So it is basically a data warehousing solution, right? And it uses SQL. In short, Hive can be known as SQL on Hadoop, right? So we'll talk about this. But before that, let's start the download. Click on the downloads link. It will redirect you to this page where you will say release now, download a release now. Click on that. And we will be downloading the file. Okay. So let me also show you the download installation steps here. Very simple, but you can see there are few steps that we have to do, right? Few steps. So we'll basically have to manage that. So here, I'll come to this. I would be using Hive 2.x. I will not go to Hive 3.x. I will stick to Hive 2.x. We're not going for storage. We are going with Hive 238. Okay, this is your stable version. And we will be downloading the bin version, 273 MB. Right? So click on this 273 MB file and download the Apache Hive software. Okay, the file which is largest, 273 MB. Hope you have started the download, everyone. Come to Hive page, main page, and there you will see downloads. Click on the downloads. It will redirect to the download page where you have a link given for Apache mirrors. Click on that, and then you will get the cloud-based URL. Click on this URL. You will get the software's locations, the folders. You can also see Hive stable version, which is nothing but 238. That's what we are using here also, right? So go with Hive 2.x. Don't go with Hive 3.x. We'll stick to 2.x. And then Hive 238. Hyphen bin is the file that we need to use, 273. Now, what is Hive? Why we need to use or why we need to talk about Hive? As I mentioned, Hive is SQL on top of Hadoop, right? It's a data warehousing tool. So organizations were having so much of data generated, and pig was used for manipulate that, store that. But when you're storing it, you need to store it in an appropriate way so that it can be consumed at a later stage also, right? You just don't want to use it for one-time transaction. You have to archive. So where do you store it? Where do you archive it, right? So that's a big problem. So in Hadoop, if I have to use MapReduce, then you'll not be able to store the large amount of file easily. That's not possible. So we wanted a solution here. Now, like Yahoo, which invented Pig, we have Facebook coming into the picture, which invented this Hive. So Facebook had a lot of customer transaction data. You posted so many things, right, in Facebook till now. So we have to store everything, right, archive it. So in order to do that, Hive is used. Now, Hive is an open source free software. It was developed by Facebook initially. Later on, it was given to community. It is basically used by data scientists, data analysts. SQL-like language. It's nothing but SQL. And as we're talking about, it is the data warehousing tool on top of your Hadoop software. Okay. Now, Hive will process the data which is stored already on HDFS, right? And when you are executing any SQL-like command on Hive, on Hadoop, then just like Apache Pig, here also the high-level SQL query is getting converted into MapReduce code for execution. Okay, and very, very important points. These two are very, very important points. RDBMS is a software which runs on a policy of schema on write. What does that mean? I have a database. Okay, this is the general syntax of a database, DB. Now, if I have to manage data or process this data here, right? Then we have SQL query, right? SQL query which is used to manipulate the data, right? It's a programming language which is very popular. Everybody uses it, right? Now, this means the data has to be in structured format. So we need to have data in structured format because your RDBMS softwares, here that's what we are talking about, they manage or they work with data which is only in structured format, right? You cannot handle unstructured data there. Structure is nothing but table, right? So when you want to store data, this is your database. When you want to store data, you need to first give the structure and then load. Hence, we call it as schema on write. So even before you write the content, you need to have the structure defined, right? Now, Hive is a little different from what we are learning here. Hive is having a concept of schema on read. Now, in big data, where does our data lie? In big data systems, that is Hadoop, our data lies in HDFS, right? HDFS is a file storage component which distributes the data and stores. And HDFS is like generic file system where you can store anything. So unstructured data can also be there here, right? Now we use Hive on top of Hadoop, right? And if I have to work with the data which is already loaded into HDFS, data is already stored, right? You're not storing it now, data is already stored. So if I have to manipulate this data, then I have to read the data first into Hive. But Hive is SQL, that means it only understands structure, right? It will only handle structured data. So when you're reading the data from Hive, you need to give that structure. Only then you will be able to read the data in table. Yeah, so we call it as schema on read, right? That's basically the characteristics. RDBMS is schema on write. That means you'll only work with structured data. Hive is schema on read. That means if you have to work on any data, it has to become structured, right? So you will basically convert unstructured data to structured format in Hive. Right? Schema full as you are trying to create a table. So we'll first come up with table schema, right, in Hive, and then we load data into that particular table from HDFS. And Hive is not real time. It cannot handle real time data. It is batch oriented. Okay, it's batch oriented. So what we've discussed, Hive is a data warehousing tool. It is SQL on top of Hadoop. It's similar to SQL query language. Right? And it allows programmers to plug in custom mappers and reducers. That's another feature. You will be able to bring in some predefined or custom map jobs and reduce jobs to be executed. Right? So this is basically your Hive. Now, if your data is in structured format, obviously your productivity increases. This data can be basically pulled out from different sources and adjusted into some standard format, right? And you'll also be able to handle large data set as well. So these are all some of the benefits that your Apache Hive gives. Now, these are the components of Apache Hive. you can see these Apache Hive components can be broadly classified into three parts. External interface, this is where you will basically be typing your commands. It's like your grunt shell in Pig. Here we have command line interfaces or various other web interfaces which allow us to write SQL queries. Then we have thrift server. This is basically like a client API, which allows you to connect with right these sources. And then Metastore. Metastore is a system catalog. It is like metadata. We're talking about metadata. Now, all the other components in Hive would connect with this metadata. Right? What is this? Let us see. Hive components. We have shell. This is grunt shell. This is Hive shell. We call it as Hive shell. This is nothing but command line interface. This is the component where you will write your code, right? And then we'll have driver, Hive driver, and this is the most important component, right? Now this Hive driver will basically handle the entire session. If you're typing one command, from the time it is executed, right? We will be looking into the driver, and driver program communicates with other components and then makes sure that the execution is completed successfully. Execution engine in Hive is responsible for executing the compiled codes. We have compiler, which is used for compiling your Hive commands. And we also have Metastore. It is like metadata. Metadata is nothing but data about data, right? So it stores about information about that data. So let us try and understand these components. Driver, very important as I mentioned. Driver acts like a controller or receiver, right? When a Hive query is executed, right, this controller or driver monitors the entire end-to-end life cycle of that particular code or executing statement, right? Of course, it also takes care of monitoring of the task as well. So we take a query, we execute it. So how should that query be executed? What resources should we use, right? All that is done by your driver program. Driver starts the execution of the statement by creating sessions, right? And session is ended, then remember the entire training or entire object space is flushed out, right? So driver basically starts this session. And this driver also stores the information to metadata, right? And remember I said it is also acting like a receiver. So you're typing a command and saying execute. So from the time that execute button is running, driver program will follow the flow of the execution command, right? So that's your driver, basically looking into the path and making sure that that execution happens successfully. Then we have Metastore. We have already discussed Metastore is the metadata, and every right command that we execute in Hive, especially if it deals with data, then that data has to be right here, Metastore. I mean the schema and everything that we're talking about, that part should be there in your Apache Hive, right? And metadata will have that syntax. Yeah. Hive works just like SQL database, guys. It works just like SQL databases. right? Now this metadata is basically the information about the flow, right? So we keep track of the progress using the information that is made available in metastore. Right? Once we come from there, metastore, we have compiler. Now remember, compiler is responsible for converting the high level code to map reduce code. So compile is converting the actual code, right? And then when we type something, it looks for the flow diagram, and here we call it as AST. This is by default available. AST, abstract syntax tree, right? On AST we write code. Yeah, we need to first check for issues, parsing. This basically is parser. Then it converts the data to AST. This AST to DAG. So it's a tree-like diagram, guys. We say, hey, do this, do this, do this, right? So this is like a tree-like diagram. The entire flow is explained here. That's your AST. Now, out of all these steps that we are trying to build on abstract syntax tree, we'll have to see which approach is correct, which approach is wrong, right? For that, we are basically checking the run compile time errors. So parsing and compiling time errors both are verified here. Then once that is done, we replace AST to DAGs. We call it as DAGs, directed acyclic graph. So out of all this AST, we'll say that, you know what, this code would be better, right? Among all, it chooses, let's say like this, right? So AST is just a tree. After checking for the syntax errors and all that, we apply your right this AST and DAG components. So first generate AST, and from this AST you take DAG. DAG is nothing but action plan. DAG, you can imagine like it is like an action plan. So compiler will compile and gives us the map reduce code. Then we have optimizer, right? This optimizer is making sure out of all the possible branches, we are trying to get the best branch. Directed acyclic graph. Right? We get optimized DAG. Now this optimizer is going to aggregate the transformations together. Right? And then finally you will apply a reduce transaction or reduce operation, or you can say eager operation. Right? So optimizer is going to fine tune the code. And then finally we have executor. This is executing the code, the optimized code. And then we also have external interfaces. This is another component, and we can use command line interface to, right, basically take the information out or do the execution of your Hive command, right? And because SQL is one of the oldest, right, I should say programming language, though it is not a programming language, but we have to call it as SQL as a programming language. So we have, right, a lot of options to deal with SQL-like queries. So we are using command line interface for dealing with SQL data. Right? Now, if I have a third-party Java platform, then of course we'll have JDBC, ODBC protocols also running on that, and we are saying from Hive we'll try to connect those databases. Now, once the connection is established, then you can write your Python codes in Hive. This is basically how we work with different tools in Apache Pig. So this is your diagram. You can see this is command line interface or web UI. Different options are available. Or we can also say JDBC or DBC. This is another option. And here we are trying to say thrift server. Right? And that thrift server basically is going to generate driver for us. And this driver basically runs through compiler, optimizer, and executor. Right? All the three. And once the code gets converted, once your SQL queries gets converted into MapReduce, and those MapReduce commands are getting executed on data nodes. Right? So this is the architecture. Basically, you can see. And we have meta store. This meta store, which is is responsible to store all the information that we are getting generated or we are generating on JDBC and ODBC, which lies on Hadoop, HDFS. Yeah, so this is the architecture. A meta store is very important, guys. Meta store is basically the data which stores the schemas. Right? It is typically implemented using tables in a relational database. So you'll have tables, right? And we are trying to recognize the relationship between the tables. Yeah, metadata comes into the picture in such cases. We are trying to work with column and column types when we are trying to load data. Any data which is there on HDFS, we'll try to first manipulate it and then read it. So let's assume there is column and a column type. So what Hive does is it takes that information and assigns it to a paragraph or basically a cell, neuron. Right? And that neuron would be executing this code. Yeah. Now, once this once the data is converted into a table in Hive, every time you want to access the data, it might not be possible to create the schema every time that you want to access the data. See, basically what we are saying, this is HDFS. There's a lot of data storage, right, physically. So we are saying read this server, right? Treat this server now. Yeah. Which basically is trying to store information that we are getting here, but I cannot store the random data as is. It is as good as copying. I need information within the file. So we are using this database. And we call it as Hive database. In this particular case, we say Hive data. And that Hive data is nothing but meta store. It's called as meta store. Metadata. So from there on, we basically are looking at information which is hidden. right? From metadata, when you look into metadata, not complete information is given, like, right, let's say by default use. By default is not something we use commonly, right? Then, for example, so these kind of frequently used data would be there. For that, it is better I define schema first upfront, so that from HDFS, if I have to access the data, then I have to access each piece separately like this, and then, right, work on it. But if I have this representation where our right, Hive software allows us to create the data like this, a table like scenario, then it's nothing like it, right? That's what we want, basically, adding BMS. Now, when you download Hive, by default, it comes with a single instance built-in Derby SQL server. It's a single hand or single instance package, Derby SQL, right? Now this is database which has single instance. Okay, it's single instance, right? Now what happens when you are trying to access that same data again? Let's say this is your HDFS. You recorded that in, let's say, third record. We are structurizing it, so I have third record. But we have multiple columns for the data set. So we'll take only that one row, and rest of the columns will remain as is. So that means you are selecting only one row. We're altering the row size. Right? Now, Derby database that we are talking about is a single instance database. Single instance means at one time you can access Derby from one account only. Right? So we cannot run two simultaneous clients of Hive command line interface. We have to basically execute it. Now, how do I get that? So what we're doing is, rather than using the default Derby dataset, Derby SQL, we experiment with MySQL, NoSQL, Data SQL, right? And then check what is the result. Right? Yeah, let me see the questions now. Yeah, Esther, what is your question?
Sir, can I ask for the previous slide, the one that is this architecture? I wasn't able to understand what's the trip server in the middle, because I understand the JDBC and ODBC is used to connect from your local PC going to the Hive. But the trip server in the middle, what does it do?
Okay, so thrift server, you can imagine that it is like a third party, right?
Third party.
It's basically, how do I put it?
Because you use the JDBC already, right? To connect to the
Yes, yes.
Hive. So it's like a third party. The JDBC is already a third party. For example, you use
See, how do you interact with Hive? If I have to write some query, how do I interact with Hive so that it understands?
from my because from my experience, I use
Mhm.
the JDBC or ODB from the Linux slide. We install the Linux, and then we
Okay.
use the ODBC or JDBC directly connecting to the Hive or the Hadoop file system, and then we can
Mhm.
access the Hive from there. So I was
Mhm.
curious, where's the trip server in the middle?
Yeah, as I mentioned, it is an optional service that you can choose, which will allow you to communicate with Hive server when you're writing the programs, right? You
So
might be
it's
using
like
third
so
party.
it's like a third part. It's like an optional one. So you can use it or you cannot use it. Is it something like that?
Yes, yes. Even if you don't want to use it, that's fine. So if I'm using any third party service, right, I'll be using that third party service or application using JDBC, ODBC. I'll try to connect with Hive.
Oh, okay. Okay.
So when I write the programs on the third-party application, it should make sure that the code, the programs, is communicated to Hive server and we get the result. So you can imagine that
Hmm.
Hive server is like a bridge between them.
Okay. Now I understand.
Yeah,
Thank you,
yeah,
sir.
sure. Right. So that's about thrift. And we also talked about the Metastore. Metastore by default is, yes, like a plugin server. Yeah, you can say that. Yes. Right. Metastore is nothing but a database which is by default given in Hive software. It is a single instance. Derby SQL Server is a single instance database. So if you're using in a local system and if you're using Derby SQL, that means you will be only having one Hive session active. Multiple people cannot access Hive. Okay, that's the challenge. So what we do in production, obviously you need to give access to multiple developers, programmers, right? But staff will be there, which basically wants to access the server. So if I use Derby, it will not be production level. So I need to change that SQL server, RDBMS server that I'm using to something which is production level, like Oracle database or MySQL for that matter. MySQL is preferred because it is open source, right? So that's Metastore and it contains, remember, metadata of your tables, Hive tables. Next, when I execute Hive query, remember it is nothing but SQL query, that Hive query has to be parsed, compiled, optimized, and then driver make sure that the entire life cycle or the value of that command is returning. The command is executing and returning the result to us, right? Now, when we try to compile and optimize the code, what is happening? In the previous slide we discussed, initially the entire command that we are trying to execute will be drafted as AST. It's like a flow diagram. AST nothing but a tree, right? Abstract syntax tree. What is your code? What is the abstract of that code? Can I have a syntactical flow? So AST will be created. Out of that AST, we need to choose the best possible solution to get the result. That single path or that one path or one solution is called as DAG. Now DAG is the optimized solution that we can use or that we can develop. So automatically everything is happening. So AST from AST to DAG. Next. Now your optimizer will have multiple transformations included, and then we can have one single action operation. But remember, SQL is declarative. Now, when I say declarative, when you're writing a SQL query, you might want to write some queries to retrieve the data based on some conditions, right? So which condition should be applied first and all that, that optimization is internally taken care by your Hive itself, the optimizer itself, and then you will have a bunch of map reduce commands which will get executed in the backend, right? And as I mentioned, driver is the most important component. It manages the life cycle of your query, right? And it moves from different stages, right? One stage to another stage. So this driver basically makes sure that it is taking that entire code or application to next level. So it is driver is taking through the entire life cycle of journey of your Hive statement. Now, when I talk about Hive, remember it has to be structured data. We are basically handling structured data in Hive. And when I say structured data, it is nothing but tables. Tables are predefined. It is a collection of rows, right? So when I talk about this tables, which is nothing but collection of rows, these Hive tables are broadly classified into two types: internal table and external table. Internal table is also known as managed table. Right? And we also have external table. Now, what is the difference between this internal or managed table and external table? What happens is, when you are trying to access some data from HDFS, it can also have unstructured data and all that, right? So we are basically creating proper, right, segmentation or proper arrangement of your data. This is nothing but data warehousing, right? You are trying to store the data in an appropriate format so that it will be easy for us to use it in future. That's data warehousing. Structured way you have to record your or right, store your data. Right? Now, if I create some table here and I'm trying to store it, where does the data go? Right? So in Hive, there is a warehouse directory that we create. This is where this warehouse is a single point of folder where all the data sets come and sit. Right? And we are interpreting the table structure for that data. So physically, that entire data is stored in warehouse directory. By default, it will be there on cloud, and it will be on user/hive/warehouse directory. That's the generic syntax. That's the path. Right? So this location that we are talking about, this directory that we are looking at here, is managed by, or it is maintained by your Hive. If that is the case, then we call this as internal table or managed table, because I have control on the table that we are creating here, right? We basically have the ownership of this directory. When I say we, Hive has the ownership, right, to the directory, right? So when we are trying to create a table and manage it, if it is there within this folder, then we say the table is managed by Hive itself. Adding rows, recording, right, removing rows from the table, everything is done using Hive only. So Hive basically has more control over this internal tables. When you start create a table, the data is getting right, stored here. From local also, you'll be able to do that. And if you're trying to read unstructured data, then you'll have to give structure to it and then store it. Right? So that's your Hive. You have managed table where the data is automatically managed by Hive. We also have external tables. Now, this external tables is very similar to what we are doing here, but the table that we are creating, we are storing it in a different location. Right? Something which is very different from this location. Now, this location is outside, right, the directory structure that the user owns. Right? So we are asking Hive, right, to store the data in an external location. Now, once it is written, Hive doesn't have control on that particular table. Right? Hive software doesn't manage it. Whereas this location, yes. This is the location. This location is automatically managed by Hive. Okay. internal tables and external tables, and converting the internal to external to internal is very simple. One single line of parameter change. Set table properties. If you say external is equals to true, that means you are going to go into quarantine, right? If you talk about the current conditions, you're going into quarantine, right? That's how we want to set the properties here as well. So if you have a table which is external, then you pass this argument external is equals to true. If the table is managed by Hive itself, then we call it as internal table, right? So alter table, table name, set properties, external is equals to true, or external is equals to false. So this is basically your internal table and external table. Data types are just like your SQL programming data types only. We have tiny integer, small integer, integer, big integer, boolean string, right, etc. We have arrays, C like structures, then maps, all those things that you can work on SQL data, right? We will be able to do it on Hive also. But one thing remember, in Hadoop, the feature says write once, read many, right? It says read many. Now Hive is sitting on top of Hadoop and it is a SQL query. That means you can alter the table also, right, using SQL. But in Hive, you'll not support any command which allows updating the record or updating the table, right? It will not allow you to alter the data which is already once stored, right? You have to be careful when you're storing the data. If you make any mistake, then you'll have to remove it and then reload it, right? So that's basically how Hive works. Write once, read many. And insert is possible from, yes. Okay, there's another point. The original versions of Hive, they did not even allow insert into a table. Right? Insert means the table size is increasing, isn't it? That means storage space is required. So Hive 1.3 did not allow, or prior to 1.3, Hive did not allow, right, big data to be processed. Right? Especially when you talk about inserting. But from 1.3 version, insert option is given. It says insert option is given, not sure. Right? And you can see Hive is nothing but SQL on top of Hadoop. Okay, so that's basically your Hive history and how it works. All you need to remember is driver, metadata. Driver program and metadata program in Hive are important for us to explore. So let us look into the installation. So I'm assuming that the software is downloaded. Oh yes, software is downloaded. Let me come here. Okay, let me open here. So Hive is the software that Hive is the software that we have downloaded now, 238 version. Now let us install and configure Hive. I'm assuming everybody has downloaded the software, Hive software. Yeah, everyone downloaded. Now what we need to do, the first step, extract it. You simply say extract the file. Yeah, so this is my folder. Now it has a very big name, right? Hive has very big name, Apache Hive 2.3.8 bin. So all I will do is rename it to this short form. You can give any name, friends. I am used to give this folder name. Hive 238. So I have downloaded the software, extracted it. Now I'm going to replace this into this folder where all the softwares are located. Right? Move the folder that you have extracted into this standard location where your big data related files are there. Right? Now, let us see the steps here for managing Hive. So there are a couple of, or not couple, there are few commands or few things that we have to do in order to configure Hive successfully. So these are the 4 settings or 4 variables that I have to set. So I will go to terminal, right? I am at the home directory. I will say gedit dot bash rc. Okay, and I will say hash dot hive settings, and just copy paste and change the location to appropriate location. Okay, this everything else is fine. You're just setting your Hive folder here. You're saying export Hive home, the path of your Hive folder. The version is 238. Right? Hive version is 238. That's what we have created here. You can see Hive is Hive-238. Right. Now, once these 4 settings, path variable is defined, class path, which uses the library files, GRE files to connect, is also imported. We save this file, bash rc, execute it. We'll say source dot bash rc, right? And you can say cross check by doing echo $hive home. This is the path where your Hive home software is installed by default. And this is the location that I have given in the file as well, bash rc file as well. Right. Now, first step, bash rc, that is done. Then we'll have to source it. Source also is done. Let us go to Hive home folder, cd $hive home. Right. Next, go into conf directory. That's where your configuration files are there. Like in your Hadoop also, we have one to conf folder, right? Here also it is conf folder that we have to use. Let us try and do that. So here when I enter into the folder, there is something called as conf folder. Open that. And these are the various files that I have. Now there are two files that we need to edit here. One is the env.sh, the other one is the default.sh or XML. Sorry. So sh file, this file is the environment file, right? Now I would have to copy that file, right, into hive-env.sh. cp hive-env.sh.template. You're copying this to env.sh. hive-env.sh will open this file, right? We have opened that hive-env.sh and we have to set Hadoop home in that file, right? You can see here, this line, it says Hadoop home. So we are going to take export is equals to dollar Hadoop home. We can do this. Hadoop home is equals to dollar Hadoop home. Right? So this is the first setting where you are pointing, specifying where the installation happened, what folder or what directory the installation of Hadoop has happened. This is the first one, right? Hadoop-env.sh. Then we need to have configuration file. So that configuration file is in XML format, but not this one, rather this one. So again, what we do, we say cp default, right? XML template. I'm saying hive-site.xml. Right? Two things that we are doing.
Hello, Sharon.
Yeah, Shruti.
Could you take it a bit slow, please? Because sometimes I'm getting lost and I'm
Okay.
not able to follow. When it comes to command, just take it a bit slow, please.
Okay. No, it's not a big
Show me
command.
the change which you have made to the previous file, which is hive hyphen and env.sh.
Okay. So let me open that file. This file contains environment settings, and we basically are setting only one important setting, that is pointing to Hadoop home. That's it.
All right.
It would be commented. We have to uncomment it and point Hadoop home to appropriate folder location where your Hadoop is downloaded and saved. But in our bash RC, we have already defined that, right? We said export Hadoop underscore home is equals to so and so path. So rather than redefining everything, I'm just taking dollar Hadoop home, which is the variable which is pointing to Hadoop location only, right? Here, rather than hard coding the Hadoop home location, you just use
Hello, sir.
dollar Hadoop home. Yeah.
Is it Hadoop Home or Hive Home?
We are in Hive software. For Hive, we have to point it to Hadoop home. It says, right, set Hadoop home to point to a specific Hadoop installed directory.
But we didn't set it on bash RC, right? We set Hive Home in bash RC. So it's like missing.
No. When we were discussing about Hadoop, we did that. Let me show you. If I go to the home directory here, and I'll say gedit dot bash rc. What did we do the first class? We set Java and Hadoop settings.
Oh, okay. Okay.
This is already defined.
Sorry for that.
Yeah, no problem. So we are just using that Hadoop home variable here in Hive and hive-env.sh file. Right? So just do that. And then is it not moving? Yeah. This is done. So let me close this. The next step is to copy hive-default.xml.template to hive-site.xml. You're just making a copy of this file to the standard name. This is the standard format, hive-site.xml. This is the configuration file. Okay, so first copy envsh, make the changes, then come back to hive-default file and make a copy of that into hive-site.xml. Now open this hive-site.xml. Let us open this. We'll say gedit sorry, not env. We'll say gedit hive-site.xml. Okay, we'll open that. When you open this, you'll have a lot of things, right? So much of content is there in this configuration file. Stay at the top and you're going to search for connection URL. Connection URL. This is the setting. And in this setting, you see Derby database is given, right? But the default database name is given as Metastore DB. But where is this Metastore DB located? That is not given. So we have to give a full path. So I'm specifying the entire path where the Metastore DB gets stored. Physically, it is a file. We see it as a file, right? But where is that actually stored? So we are storing it in a folder called big data in this file. In this folder, right? So save this change. You basically look for connection URL setting and then change the database name by giving the complete path. Done. Take a copy of hive-default, right? .xml.template. And then here we also use the standard name, the XML file format, the standard file name syntax that we use is hive-site.xml. So the software, the component -site.xml, right? Any component, if I talk about Hadoop, we had hdfs-site.xml. Remember? This was the configuration. Core-site.xml. So this is the standard syntax, the component -site.xml. Right? So here we basically take that hive-site.xml and update this. Give path. Metastore DB is the name by default. We are giving the path. Okay, this is the first setting that we need to do. Okay. Next, if I don't do that, then you basically will not be able to have what happens is when you don't give this full path, if you're giving only metastore underscore db, the challenge is that when you're initializing Hive for the first time, this metastore db will be created in the current working directory. Okay, whatever location you are at that particular instance, this folder will be created there, metastore db. Okay, but if you are trying to run Hive from any different location, it will not work because path is not defined. You have to manually go to that location and then do it. Right now, if I give the complete path, then your operating system or Hive command when you're executing will understand that the metastore db is in a specific location. You have given the full path, so it will be able to identify. Right? So that's the idea here. And then once you save this site.xml file, and if you want to start Hive, you will get this error. Relative path in absolute URL. So there are these two parameters, right? These two parameters are not defined anywhere in the system. So you will have to define it. What are the settings? system:/java:/io.temp.dir, temporary directory. If you want to execute something, you might want to give a temporary location, right? So where is that temp location? You have to define that. So here I'm defining it as /tmp. The standard syntax that we have learned in Hadoop configuration files will also be applied here. You'll have property. Within the property, you'll have parameter name and the value to the parameter. So this is for input output temporary directory. Here, this is for the username. Right? So we add these two at the top of your Hive-site.xml file. I'll come all the way to the top, and under here, I'm going to execute these or save these locations and files. /tmp by default will be there, and the username is user2. Right? Save it. So that's it. Right? We basically have these two settings to be done. Now, by default, on Hadoop file system, these two folders will be created. If they do not get created automatically, then you manually create them. And these will be created when you execute Hive at least once. Right? Now, once these settings are done, you might want to initialize the schema. Like in Hadoop, we have formatted our data set, right? File system, right? Name node format, remember? So that command is basically tweaked here. We are trying to initialize the schema because it is RDBMS. We're initializing the schema. Okay. So let me save it. Okay, let me save this, close it. Again, we'll edit. We have saved. Fine. So we are successfully saving it. And then we have to use the schema tool. Let us try and implement schema tool. I don't have to type in. I use tab button twice. So it gives us the schema tool. I'll just type schema tool and execute. It will give you a hint on what all commands we can use with respect to the schema tool function. So schema tool usage, these are all the various options that we can run using schema tool.
Sheriff,
So,
when I type in schema, it says that command not found.
sorry?
When I type in a schema,
Hmm.
there's command not found.
Schema is command not only. What you have to do is schema tab button. Press tab, not enter. Did you type tab?
Yeah.
So now you get those two options, schema gen and schema.
Yes. Yes.
Then press T and again press tab, it will autofill. Right? And when I enter schema tool, it is giving us this option. This is the function. And these are all the options. This is the command, schema tool. We are trying to initialize the schema. Okay. So I'll say init schema. You see the option init schema is the argument. Schema tool space hyphen initialize schema. But what schema you want to do? You want to initialize schema, but what type of schema? So we are saying db type hyphen db type is Derby. Your database is Derby, right? So you're basically saying schema tool initialize schema on Derby database. DB type is Derby. When I do this, let it execute. When I do this, it is basically going to create your Metastore DB in this location. And you should see this command. Initialization script completed, schema tool completed. Now, if I go to the location where I decided that my Metastore DB is created, this is the folder, and you can see that Metastore DB is created here. That's it, guys, done. So once you are able to successfully initialize the schema, that means we can start Hive. And to start Hive, you will just say Hive enter. It's now starting the Hive session. Yeah, everyone do it. Connection refused. Why do you think connection refused is coming? Anyone? I'm getting connection refused error. Why do you think it is coming? Why, guys?
Hadoop, that means node manager and all those need to start.
Very good, very good. So my Hadoop services are not started.
Yes, sir. Yes, sir.
I'll start dfs.sh. Strange. Data node service is up and running in the backend. Okay. Data node is not started. Data node is running. It says it is running. but when I see JPS, it doesn't show data node. Okay, let me stop gracefully and see. Okay, name node, stopping data node now. Stopped secondary manager also, node, secondary name node also. GPS. Fine. User 2. Hopefully this time my password data nodes are also started gracefully. This time it started. Now I'll say start hyphen yarn.sh and start yarn related node manager and resource manager. And I have 1, 2, 3, 4, 5. So all my services are up, and now I'm saying Hive. Look at that. Hive is installed. So you'll say show databases. SQL queries. Right? Very simple. SQL commands. Show databases, create database, right? You use the database, etc. By default, there is a database name called default. This is already there. OK is basically a command which is run or which is shown every time a command is executed. Yeah. So here show databases. We can try and do other queries. So if I want to create a database, we'll do this. Okay. Very simply, we'll follow this. It's very easy. So we'll create database test. SQL, right? Now, if I say show databases, you will see both the file, both default, which is by default available, and test database. Right? So we created 2 databases. Now, let's say you're logged in and you don't know what is the database that you're working on with. There might be multiple databases in a single system, and you don't know which database you're working with. So in such case, you can say CLI.print name, something big name will be there. Let me try and recollect it. Says, okay, set Hive CLI, okay, Hive CLI. Hive.cli dot print dot current DB is equal to, if I say true, why is it not coming? Set hive.cli.print is equals to, okay, my bad. I have to pass this as is. Now when I execute this, you will see it says default. It is showing you what is the current DB that you're using. I want to use the test DB that I've created. So I'll simply say use test. So from now on, the default database is moved to test database, right? So in this, I want to see tables. Show tables. Because it is empty database we just created, it will be nothing. You want to create a table. Now, how do I create a table in SQL? We'll say create table T1, and then we have to give the schema. Create table, table name, ID and name, right? So you'll say ID, you'll say teacher, names, comma, string, or you can say array. You can say name can be string, or you can also say array. So I'm using string here. We can also say, as I mentioned, array can be used. So I'll say string. And semicolon is must. So now if I say show tables, you see T1 will be there. Right? T1 is there. Right? So this is your simple SQL queries. You can also say describe T1. It gives us the data types. ID is integer, name is string. I want to load some content into it. Then we can also do that. But before I load a content manually, imagine that you already have some content on HDFS. Some file is there in a local or HDFS. Now you want to store that data into Hive table. Right? So in order to do that, first let us create a local empty file with this particular content. Yeah, I copied this text data. I'll come here. I will open a new tab. And here I'll say gedit sample.txt and just copy it. But one thing you need to remember when you do this copying is that the data cannot have space between them because of the last column. Otherwise, we can also use space delimiter or comma delimiter concept. But in our code, we are using tab separated. Like this. Why tab? Because space would basically create confusion, especially because your designations are words with spaces. So it will create that confusion. Hence, not space, but tab after the content. So it's a manual step. I'm just creating some random data, but this data is tab values separated. Save this, right? You can say sample.txt is there here. You can say cat sample.txt. This is the content. Now I want to load this data into Hive tables. So we need to first understand the data. This data, I have ID, I have name, I have salary and designation. So we have to define the structure for this particular table. We have to define the schema, right? So I say create table emp ID, is equals to integer, right? ID is equals to integer, name is equals to string, then name is equals to designation, no, salary, sorry, salary is, you can put anything, let's put string, comma, string means it is treating the data as non-numeric data, okay? So string, yeah, and designation is also string, right? Designation is also string. Right. So these are the schema, but you also have to give the syntax on how you want to identify your data. So this table is basically row delimited, right? Row format. The data is in row format. The data, the content that you're trying to give is in row format or in table format. Delimited, it is delimited the fields with tab separated values, right? Delimited fields, delimited fields terminated by there are some use uppercase commands also. I'm trying to figure out. Terminated by /t. Create table EMP. The row format delimited by okay, fields right, row format and delimited fields by /t and lines are terminated by /n. /n/, right? So I'm creating structure, guys. And we are saying the data is stored as text file. Stored as text file. So we are creating a table. The table name is EMP and it has 4 fields. Rows are separated by /n. Each row is separated by /n. Lines are terminated, right? Each row is terminated by a new line character. And the columns or fields are basically terminated by /t. Right? Next, if I say describe EMP, you will be able to see the syntax of each column. Right? Now, I have this file. Where is that? Sample.txt file located in this folder. And this is in local. Right? So I want to load the data which is there in the local file system in path /home/user_t and the file name is sample.txt. So this is how we read the data, right, into the table. So I'll say load data local in path. Say in Hive again, I say load data in path, load data local in path, sorry. Right? load data local from local in path. This is the slash path that I have. Slash home. Slash home. Slash user2. Slash sample.txt. Load into your data table name. Overwrite into, not load. Load is already given here. The first keyword is load. If my table, EMP table already consists, right, already consists of something, then we are saying overwrite it. Overwrite EMP into EMP, sorry. The syntax is sometimes a little confusing. Missing table EMP. What is missing? Load data local in path table name, file name overwrite into table EMP. I've written the same thing, right? Load data local in path over. Okay. Keyword is missing. Now what is it doing? Loading the data to table test.emp. Test is the data set, instance name or database name. Within that, we have a file called EMP or table called EMP. Now you can say select start from EMP and it will show you the content. See? So I have a data set from which I'm reading only selected files. You can do that. Right? Imagine that your sample.txt has a lot of things. From that, you are loading, right, few of the columns. We can always do this. And we will get structured data. Right? Now you can cross-check here Hadoop fs -ls slash, I'll say -r space slash. Recursively, you want to check all the values that are there in Hadoop. So look at this, this slash tmp was not there previously, now it is created. It is also creating slash user hive and warehouse folder. Within that warehouse folder, I'm creating a database folder called testdb. And within the testdb, I have created a table called EMP. And in that EMP table, I'm storing this data, sample.txt. And it has 161 bytes data. That's the size of your data. Now, these are internal tables because we have the tables basically managed within the folder which is managed by Hive itself. Now this table is empty. Table is empty. If I want to delete a table, it will be very easy if the table is empty. But if the table has some content in it, then I will have to use cascade command to drop the table completely. Right? And these are some of your SQL queries that you might want to work on. Just type in these commands so that you are basically getting the results.
Answer question.
Yes.
For the insert, the one we use override, right? Can we use, for example, append or concatenate? Because I'm for that one.
All options are possible here, Ashna. In Hive, we cannot use a lot of options which will update the table. Remember, it is ultimately writing into HDFS, and HDFS has a feature called write once, read many.
So it means, sir, that here in the override we cannot use another syntax like concatenate here. We cannot do that anymore, right? Because it's once right, read many. Is that correct?
Yes, yes,
Okay.
yes. There are few commands, Ashna, that we need to explore. These are very simple, basic commands that I have shown. But on top of that, yeah, there are few things that we need to learn.
Okay, sir. Thank you.
Yeah, you might want to just run all this. I'll drop the table. Let me also show you the drop table command. So very simple. You'll say drop table T1. That's it. And the table is dropped. OK means confirmation. Right? Now, if you say show tables, it will show only one table, EMP. Okay? So this is how we handle Hive, guys. Yeah. Any questions?
Sir, I'm unable to copy that again like yesterday, sir. To big data folder, that tar file, sir. That means downloaded file.
You're not able to copy?
Yes, sir, like yesterday.
What you're not able to copy?
That folder is a tar folder we have downloaded now. Hive folder.
Yesterday, what we did?
Sir,
Yesterday
sir,
we extracted, right? So how did you extract the file?
same like I'm doing, but I'm not getting again, sir.
You're not moving ahead. See what happens. You see the options on the screen.
Okay.
Try out all the options. Maximum what happens, the system gets corrupted. When I say system, the software gets corrupted. You can uninstall and install. You should not have the fear. Explore. Just see what options you see on the screen and click randomly and you'll be able to figure it out.
Okay, sir.
See, try.
Okay, sir.
Got it? Yeah, did you get it?
No, sir, I'm doing now.
Okay. You see extract folder, extract button somewhere. Do you see the extract button?
Sir? Yes, sir.
Did you click on that extract button?
Uh,
Okay, share your screen.
okay, sir. This one only, no, sir.
I don't know, you try out. That's what I'm saying, right?
Okay. And all files I have selected and again need to extract this one. Replace the files.
What does it say? What does it say?
Another file with the same name already exists. That means already it has been downloaded. It has been downloaded.
You can cancel this, right? You can close this.
Okay, sir.
Go and check into the folder. Do you already have the folder extracted here? Where is the software located? So where did you download?
So downloads
Go to that folder.
here. Sir.
That is the zip file. You have unzipped it already. What will be the name of the file?
And the first
Apache,
one is
yeah.
the unzipped one. Yes, no. The first one, I think. First one.
Let her figure out. Let her figure out, Shruti.
Okay.
This one, sir.
See,
Zip file.
it's there on front of our eyes. We fail to figure that out.
So,
Yeah. So we've already done.
sir?
You already downloaded it, right?
Yes, sir. Yes.
Now you'll be able to access.
Oh, sir, thank you.
Sure. You should not have the fear of failure, guys. This is nothing. This is just a software. Randomly experiment whatever you want to do. Let it fail. That's okay. Only then you will learn. Again and again, I'm saying this is all not required for a data scientist. But why we are doing it? So that you understand the architecture, you understand the file system that we are playing around with. Now, if I use an automated template, you will not understand what does Derby database means, what does that metastore file means, why is it creating and all that. Right? So that's the reason why we are doing these experiments. Okay, you started Hadoop services, but still Hive is refusing. Okay, what is the error that you are seeing, Shilpa? Did you do JPS and all? Do you see all the services up and running? Okay, when you say Hive, what is the error that you are getting?
Some Java connection exception error I'm getting, sir.
Java connection exceptional error. Is this the error that you're seeing?
That is not there, sir. I'm getting different error other than that.
Okay, different error. Okay, share your screen. If it is different error, share your screen. Let me see.
Shurith, are we done for today?
Yes.
All right, then. Take care. Have a
Yeah.
good weekend, everyone. Take care. Bye-bye.
That's okay. Leave it.
This is the error I'm getting, sir.
Let me see this. You have to scroll up. Wait. Slowly. Let me see. Slowly go up. No, the messages. Yeah, not messages. Yeah. Little up. Wait. It is Hadoop error only. Hadoop is not started.
Started, sir. Let me show you.
Okay. What is IP? Do if config. IF config. Hmm. 192.168.2. Okay, scroll up now. Let me see that error message once again. Up. Scroll up. Wait. Connection refused. Okay. Do one thing. Say Hadoop. Type Hadoop. FS -ls /. Enter. You should get the same error. This is the error because of the internet connectivity that you are doing. Probably might have changed the internet, or you might have accessed this Hadoop from different IP addresses, different internet connections. So what is happening is the IP address is changing dynamically, right? Because of your internet provider, it basically changes. But when Hadoop started, it has recorded one IP address in the backend. So you're seeing that same IP address now, right? So the problem is you need to shut down Hadoop services, and then probably you might want to reconnect your VMware, restart your VMware, and then start using your Hadoop. That should work again.
Okay, sure. Okay, thank you.
Yeah. Shut down Hadoop services first, okay? Then restart your VMware.
Sure, sir.
All right. Fine. So we'll stop here, and the next class would be HBase, and then we'll talk about Scoop. We'll not get into the, too much of hands-on, but after that we'll start with Spark. Spark will go in detail, right? So yeah, we'll connect next week, Monday. Until then, thank you guys. Good night. Take care.